This is our Maker 485 shield, and we need two of them for communication. This one is the peripheral, and this is the controller. They're the same thing. What determines the peripheral and the controller is the settings that you have here on the gold parts, as well as your wiring. I'm using DuPont cables, but you can use a telephone wire for this. The ISO ground on the peripheral is connected to the ground on the controller, and then Y and Z on the peripheral are connected to A and B on the controller. And then that's it. You simply mount to your Maker board, whether Wi-Fi or whatever, and then program that, and that's it. We finally have everything connected. Now recall, the controller has this cable coming into ground, and so this is what we have. We have our Maker 485 shield, and we have our Arduino Wi-Fi, Maker Wi-Fi 1010, and the controller doesn't need to have any sensors on it, so that's what we have here. And then here we have our Maker Wi-Fi, and it could be any maker. And then we have our ENV shield, and then we have our 485 shield. So the connection is between the 485 shield, and that's what we're going to use for our communications. Let's send temperature and humidity data over the RS-485 using the Maker 485 shield. So first of all, let's include the libraries. We're working with Maker ENV and Arduino RS-485. You can check the library for these and make sure that they are installed. And then we have our constants and variables declared from lines 4 to 7. Within our setup, we set our baud rate for the serial monitor, and then we try to initialize our ENV shield. If that fails, we log that out on line 12. If it succeeds, we log that out on line 15, and then we initialize our RS-485 shield, and we set our baud rate to 9600. And then the next thing that we do is we loop every 60 seconds, which is on line 20, and we get our temperature and humidity readings. We create a string by concatenating the station ID, the temperature, and the humidity. We log that on line 25, and then on line 27, we call begin transmission on the RS-485. We print out the message with a line terminator, and then we end transmission on line 29. And that's it. So I will put on the microcontroller, ensure that I have the right board selected, which is our Maker Wi-Fi 1010. Make sure that's selected, and then I will upload the sketch. Okay, that didn't work, so I will reset. It's going to be a bit difficult. Okay, let's try that again and see. Okay. Let's give this another try. Not sure why it's not seeing our device. Okay, I'll just pause this and try to sort out. Okay, let's try this again. Okay, that's uploading and our upload is done. So let's open up our serial monitor. And we might have to wait up to a minute if we've missed the messages that were at the top. Then we'll have to wait a minute to see our message get printed out. And there we have it. So it means that all of the execution in our setup happened and we're within our loop. And in our loop, we've got this. And then we have our message that gets transmitted. And that's it with our sketch. So let's receive data being sent over the Maker 485. So you've already seen the video with the setup with the two Maker 485 shields. There's a peripheral that has an ENV shield. This is the controller. The sketch is pretty simple. We have an include on line 1. We have a setup. Within our setup, we set a baud rate for our serial, and this time around we set it to 9600 so that we can channel whatever is coming over RS-485 straight onto our serial. And we just pause if the serial isn't active. And once we open the serial, we will initialize our RS-485 shield with a baud rate of 9600. And then we will just enable reception. And within our loop, we just keep checking whether there's anything. And if anything comes in, we take that and we write that out to serial. It's that simple. So I'll just power up the microcontroller and just a second while I make sure it's working. Okay. It's been a little bit finicky. I hope it's not broken. Okay, we've got power and yeah, we can see our board here. So let's go ahead and upload our sketch. Okay, upload is working and our upload is done. We can go ahead and open our serial monitor and all we have to do is wait. So we've got the peripheral sending messages and let's just wait It sends out a message every minute, so we might have to wait up to a minute to receive some data. It's been more than a minute. Let me confirm the previous sketch will work. It works without the serial monitor. This is the one that requires the serial monitor. Oh, yeah. Oh yeah, apologies. I forgot to set the correct baud rate. But it looks like we got data. So yeah, let me leave that at the correct baud rate, and Let's wait for some data to come in. Okay, we have some data coming in, but it's not displaying correctly. Let's see. Let's look at the sketch required for taking meter readings from a Modbus compliant electrical meter. You're going to need the Modbus library, and so you can check the library here for it. The wiring and the setup between the meter and the RS-485 shield are explained in the book, so make sure you check that out. And we have only two libraries that we're including here on lines 1 and 2. The next thing within your setup is to set the baud rate for the serial monitor, wait a second and a half, and then start the Modbus client. As you can see here, we're also using a baud rate of 9600. Once that succeeds, the next thing is in the loop, and within the loop, we'll simply call this get energy function and then print that out to serial. So let's go take a look at the get energy function, which is at the bottom. And within that function definition, we start with a variable to hold our energy reading, and we set that to 0. And then we have to call the request from method of the Modbus RTU client. And that requires setting addresses and holding registers. But you should check out the method definition and documentation for additional details. If this doesn't work, then we can print out an error. Otherwise, what we read was a word. So we need to read the first word and then read the second word and then the third word. And then we need to concatenate these. And what's happening here is simply a left binary shift. And then we divide by 1000 to get our kilowatt hour reading. And then we return that. So it's just a little bit of math. Note the left binary shift here, but be sure to check out the documentation for that. And that's all that there is. We can then, if we have our microcontroller running, we can upload the sketch to our microcontroller. Okay, so our sketch is uploaded, no errors. I don't have this connected to the high voltage meter at the moment, so we're not going to be able to see any readings. But that's it. Thank you.